Welcome. So now we're going to learn about circles. Some vocabulary words we're going to learn are chord, diameter, radius, secant, and tangent. We're going to learn to find the measures of central angles. For instance, the 13 stars of the Betsy Ross flag are arranged equidistant from each other and from a fixed point. The distance between consecutive stars varies depending on the size of the flag, but the measure of the central angle formed by the center of the circle and any two consecutive stars is always the same. Right? So distance will change if the size of the flag changes, but the amount of turn, and an angle is the amount of turn, that won't change. If we look here at this flag, oops, let's try that again. I wanted yellow. I got blue. This is the center of the circle. A segment that goes from the center to the edge of the circle is a radius. If we look between the angle between two radii, it's a little big there. There we go. I'll fix the word center. That would be a central angle. It's hard to write on this flag. There's not a lot of space. There we go. We're going to learn how to find the length of a tangent, find the measures of angles formed by chords and radii, find the measures of inscribed angles and their intercepted arcs, including finding inscribed angles that share arcs and tangent chord angles, and find the measure of angles formed by secants and tangents. In this particular lesson, we're going to learn to find the measure of radii, diameters, and tangents. We're also going to learn some key vocabulary and a few theorems to help us out. And we're just waiting for the page to turn. There we go. This is in your notes. I have 3 circles here. I'll just call them, I got a first circle, a second circle, and a third circle. And we're going to look at some features on these circles. So a circle is defined as the set of all points in a plane that are equidistant from a fixed point called the center. A circle is named by its center. So over here, let's say this point is point P, then that would be circle P. A chord is a segment that joins 2 points on the circle. Right, so here we have a chord. It goes from point J to point K, so it goes between those 2 points. Right? It stops at those endpoints. That would be a chord. That would be chord JK. Notice that we use the symbol for a line segment, right? Because a chord has a fixed length. So if it has a fixed length, there's no arrows, it's not infinite, right? We use a line segment. In the second example, let's draw in a chord and secant. And actually, I'm going to use a line tool, so it's actually a straight line. Right, so, and I might have this already drawn in your notes, but by hand. Let's say this is point H, and this is point J. Right, so now, if we just look at the distance between the 2 points, where the endpoints are on the circle, that would be segment HJ, and that would be a chord. And notice I used the symbol for a line segment. We also have a chord over here. Let's call those points Q and R. Right? So that would be chord QR, and I use the line segment symbol. A diameter is a chord that contains the center of the circle. So this diameter here is also a chord. It has its endpoints on the circle, and we can give that one a name too. S and T. Right, so that chord ST is a diameter. So a diameter is a chord that contains the center of the circle. There are an infinite number of diameters in a circle. All diameters of a circle are congruent. Right? They're also a diameter, we can add this to your notes, a diameter is the largest chord in the circle. The radius is half the measure of the diameter. A radius has endpoints on the circle and the center of the circle. All radii of a circle are congruent. So if ST is a diameter, then segment PT is a radius. Goes from the center to the edge. And there's an infinite number of radii, just like there's an infinite number of diameters. A secant is a line that intersects a circle in two places and continues through the circle. A secant slices through a circle and contains a chord between the 2 points that lie on the circle. So if we extend chord JK, we will have secant JK. Notice for secant we use the line symbol because a secant is infinite. It'll keep on going. Right, so we had chord HK, but if we don't, HJ, if we don't stop at those endpoints and we keep on going, then we have line H. That's my glitchy part. Line HJ and line HJ is a secant. Hence we use the line set, we use the symbol for a line because it's going to keep on going. All right, so now we've looked a little bit at chord, diameter, radius, and secant. Let's look a little more closely at at diameter and radius, and maybe a teensy bit at chord. Oh, and by the way, I hope it was clear. This was in your notes. I don't know if I remember to say this at the beginning. Make sure you fill in all the words that are missing from your notes. They are the words that are in red. So in your notes, you'll fill in circle, equidistant, center, and center. Second one, chord, 2 points, circle, and so forth. Right? So don't forget to fill in your notes. And if you're watching this on your own, then pause the tape so that you can get your notes filled in. If this is live, then I'll pause the tape for you. So RC is a chord of circle A. A chord is a segment that has endpoints on the circle. So the chord's endpoints are at R and at C. MT is the diameter of circle A. A diameter is a chord that goes through the center of the circle. All diameters of a circle are congruent. What are the radii in this diagram? Probably the most obvious one is radii AM. Right? It goes between the points M and A. By the way, it doesn't matter whether you name that MA or AM or MA. Right? They're the same thing. We have another radii, a radius, radii would be plural, another radius at, yeah, radii is the plural. We have another radius at AT, and we can call it AT, or we can call it TA. Doesn't make a difference. Those two are the most obvious ones, but if you notice, there's a segment that goes from A, which is the center of the circle, so this is circle A, to R, which is a point on the circle. So that means that AR, or RA, is another radius, and so is AC, or CA. Right? And they all get this symbol for a line segment. Oops, we missed these two. Right? Because they are finite. One thing that's special about all those radii is that they're all congruent. So AM is congruent to AT, which is congruent to AR, which is congruent to AC. Right? They're all congruent to one another. And we could mark that here on the diagram, right? So all of these are congruent. Now you might notice that the two radii, RA and CA, and that chord, RC, create a triangle. And there's something special about that triangle. And you might see a question that might come up on a benchmark or a formative or a test that asks you to find the angles in that triangle. Right? Well, notice that the radii are the sides of that triangle are formed by the radius of a circle, the two radii of a circle. And radii of a circle are congruent to one another. We can use base angle theorem to find the measure of the angles. Now we would need to know one angle, any one. But if we knew one angle, we could find the others. Remember base angle theorem, the angles opposite congruent sides, and this would be an isosceles triangle, are congruent. Right, so not only are those sides congruent to one another, but the angles opposite the congruent sides in this triangle are also congruent. So this angle here is the same as this angle here. If this is in your notes, I don't remember, then add the markings to your notes. If not, just remember that theorem, right? And you can use it when you have a similar problem. Let's find some measurements of, we need some number values here, but if we have some values, we could find the measurements of some radii and some diameters. And this next part is in your notes, as soon as it changes. All right, so the relationship between the diameter and the radius. The measure of the diameter d is twice the measure of the radius. I'd like you to put this part in your notes, that 2 radii equal a diameter, that's what the first one says, d equals 2r. Or the radius is half the diameter, right? So if you know the radius, double it, you'll get the diameter. If you know the diameter, divide it in half, and you'll get the radius. So if MA equals 5 inches, what's the length of AC? Well, notice that AC here, which is from A to C, is also a radius. MA was a radius, and AC is a radius, right? They go from the center to the edge. So AC is congruent to MA, and therefore AC is also 5 inches. How about the length of TC? Well, TC goes from the, has its endpoints on the circle and goes through the center of the circle. So TC is a diameter. And we know that diameter equals 2 times the radius. That means that TC equals 2 times 5, which is 10 inches. By the way, you might notice that AC and TC over there do not have a line segment above them. We don't traditionally put the line segment above if we're talking about the measure of something, right? Then it's a value. If we're naming it, then we put the symbol above. Right? So not too difficult to find radius, diameter. If you know the radius, you just double it. I have some for you to find, and then we're going to go over them. Now you won't get a picture, but that's okay, because I'm telling you which is the radius and which is the diameter, right? So here, if the diameter of a circle is given, find the radius. If the radius of the circle is given, find the diameter. This is going, so the tape is going to pause and you'll see these 4 problems. I want you to type in the missing one. So for the first one, you'll find the radius. For the second one, you'll find the diameter. The third one, you're given the diameter, so you'll find the radius. And the fourth one, you'll find the diameter. Right? So to earn the points for this question, make sure you put your answer in before I go over the answers in class. All right, so the tape will pause, and then we'll go over the answer. You'll put the answers in, and then when the tape resumes, then we'll go over the answers. Right? All right, thank you for filling in your answers for the radii and diameters. Let's go over the answers and you can see how you did. All right, so the diameter is 27 inches. The radius is going to be, remember the radius is half the diameter. Actually, I had those notes up there on the top. So the radius here is going to be half of 27. And you could write that as 27 halves or 13.5. Either way, that was correct. Here in the second one, the radius is 5.8 centimeters. The diameter is always twice the radius, so the diameter is going to be 2 times 5.8. Oh, and I forgot to put the units of measure there. By the way, if you didn't put the units, it's all right. We should get into the habit of that if we have units. So the diameter is 2 times 5.8, or 11.6 centimeters. In the third one, the diameter is 9.2 feet. The radius is going to be half of 9.2. So that's going to be 4.6 feet. And then the last one, we're given the radius. We want to find the diameter. So if the radius is 19 feet, the diameter is going to be 2 times 19, or 38 feet. Right, and that's all there is to finding radii and diameters. Right, I hope you did real well on those. Right, but if you made a mistake, so long as you understand, maybe you just made a little math error, right? As long as you understand how to do it now, it's okay. And just waiting for the page to turn, and it's turning now. All right, so we've talked about secants, and we've talked about circle and 2 points. So line L here is a secant of this circle. We could also call that, you should put this in your notes, we could also call that line AB. Ugh. All right, well, I'm going to write it down here, and then I'm going to move it into the right spot, so it won't be so wavy. There we go. Right? So a tangent is a line in a plane of a circle that intersects the circle in exactly one point. This one point is called the point of tangency. So line K is a line K is a tangent. We could also call that, I'll put it over here, I guess. We could also call that line DE. Right here, D, and I should label your circle, is a point of tangency. Let's actually label these as, okay, so label point of tangency, label this as the secant, tangent. I don't know why I said that. Probably because secant was first, and then I decided to write tangent in first. Probably because I decided to write tangent in first because I had the green pen in my hand, and the tangent is green, so. And then write in secant next to the secant. Right? So a secant will intersect the circle twice. The tangent only intersects the circle once. And because of that, there's some unique things about tangents that we're going to learn about. And waiting for the page. I didn't like waiting for the page music. All right, so a tangent, and this is in your notes, and I think it's all filled in except for where I put a little blue asterisk. So a tangent intersects a circle in exactly one place. So the tangent, has two defining properties. It intersects a circle in exactly one place. The tangent intersects the circle's radius at a 90-degree angle. Therefore, the tangent is perpendicular to the radius. All right, so here we have a tangent. So tangent A, we have AB. AB will be a tangent. In this case, it has endpoints, so it's, let me write that, let me put that in yellow. Right, so tangent, so AB is a tangent because it's and point C is the point of tangency. That's where the tangent intersects the circle. Right? CX here is a radius. Because AB is a tangent, AB is going to be perpendicular to CX. Right? So radii, tangents are perpendicular to the radius they intersect. At the bottom there we have not a tangent. And not a tangent does have a name. Not a tangent here is line segment JK. It is a secant even though it's not a line because it does go outside the circle. It intersects it in two places and goes outside the circle. It just doesn't keep on going forever. And it could stop. Usually they just keep on going, but this one decided to stop. Maybe it got tired. All right, in the bottom picture here, we have another tangent. And do label the diagrams for me. All right, so VK is a tangent. We don't have a point of tangency drawn in here. We could draw one in, but let's draw in the right angle. And actually, it would be nice to have a point here. Let's put in a point. We have an X already. We don't have a T. T. All right, so point TX is a radius. Since VK is a tangent, VK is going to be perpendicular to TX, right? The two segments intersect at point T. Point T is the point of tangency, and the tangent is always perpendicular to the radius. Here we have not a tangent. Not a tangent. GU here is a secant because it intersects the circle twice. It intersects the circle kind of close together, right? But it still intersects the circle twice. All Right, we're going to do a few problems. We're going to learn a little bit more about tangents, right? And then there's going to be a labeling activity that I'm going to go over in the next tape. All right, so tangents and circles. A tangent to a circle is a line in the plane of a circle that intersects the circle in exactly one point. And this is true if you spin an object in a circular orbit and release it, it will travel on a path that is tangent to the circular orbit. So here we have the discus thrower. He's spinning in a circle. When he lets it go, right, the path that that discus is going to take is going to be tangent to that circle created with his arms. And this is in your notes, if a line is tangent to a circle, not the picture, but the bottom part. If a line is tangent to a circle, it is perpendicular to the radius drawn to the point of tangency. So here you have this diagram. I think you just need to add, and actually I think even the writing is in there. All right, so if line segment AB is a tangent, D is the point of tangency, and OD is going to be perpendicular to AB. Point of tangency is a vocabulary word. It's where the tangent intersects the circle. That's the point of tangency. Okay. All right, so common tangents. Common tangents are lines or segments that are tangent to more than one circle at the same time. All right, so if you have two circles, the most tangents you could possibly have are 4 common tangents. That'll only occur if you have 2 completely separate circles. In other words, they do not intersect each other in any way, shape, or form. You have what's called 2 external tangents. Right? In this particular diagram, they're in blue. They're outside the circle. And 2 internal tangents. They're between the circle. The one thing I want you to add to your notes, and this drawing is not in there, but find a little place to add it, that external tangents are outside the circle, internal tangents are between circles. Right? So you can distinguish. If the 2 circles intersect in one point, right? In other words, they're tangent, then we've got 3 common tangents. Right? So we've got one tangent. Draw it in purple. We have one tangent that is between the 2 circles right there. Everyone see that? That's the internal tangent. And the point of tangency, both circles and the tangent line intersect in exactly one point. Right? So that point of tangency for the 2 circles is exactly the same. And then we have 2 external tangents. Notice that we have this tangent here intersects the blue circle about there, and this one, the same tangent, intersects the red circle about there. And then we have another tangent that intersects both circles in one point. Right? So that's how many you can get if they don't overlap, but they do intersect. If the 2 circles intersect and overlap, then we can get the 2 external tangents, but there's no way to get an internal tangent because anything that's a tangent to the red circle is a secant to the blue circle, and anything that's a tangent to the blue circle is a secant to the red circle, or, oops, I missed it. There we go. Or nothing to the red circle. All right, so I'm going to get rid of all these lines. Oops. All right, let's try it with the mouse. See if we can get rid of those. And cut. Because I don't want to confuse you. These are not tangents. They're tangent to one circle or the other, but not both. And cut. There we go. And cut, they're gone. All right, so we just had the 2 external tangents and no internal tangents. If the 2 circles don't overlap, they intersect in a point. In other words, one's inside the other. We have 2 internally tangent circles, meaning the 2 circles intersect in a point. We can get 1 external tangent, and it's where the 2 circles intersect. Right? We can't get any external tangent, internal tangents, because there's no inside between these two circles, right? They overlap one another. And we got one more situation here. So now you see where we have 4, 3, 2, 1. So 4 is the most. Then we could have 3 if they intersect in a point, 2 if they overlap, 1 if they intersect in a point but one's inside the other. And here's how you have no common tangents. If you have 2 circles where one's inside the other, and it could be that they have the same center, so they're called concentric circles, or it could be they have 2 different centers, right? There's no way to get, whatever's a tangent to one is a secant to the other, right? Or nothing to the other. So there's no way to draw any tangents here at all. All right, so this is going to be a draw it, and then in the next video, which is going to come right after this one, we're going to go over the vocabulary words and see how you did in naming the vocabulary words. All right, so I'm going to take a little pause, we'll take a little break. You go ahead and do this problem, and then I'll see you in the next video. All right, bye for now.